Furthermore, we can see that my player takes a much longer time to accelerate, as we can see from the flat line here, whereas the model player straight from the blocks has a very quick acceleration. This shows that the model player gets away from the starting line very quickly. This is beneficial in basketball because it will mean, because as an example, if there is a ball that is uncontested, the model player will be able to accelerate quicker and get to the ball before the other players will. Whereas for my player, their lack of acceleration will only hinder them when it comes to trying to win 50-50 balls. In the middle part of the run, you can see there is a spike in my player, in the weaker players' acceleration, showing that they have finally opened up their legs and have got to their full speed. Whereas with the model player, as they have reached their top speed, it starts to come back down as they cannot accelerate anymore. And then for the model player, as they get to the last point of their 20-meter sprint, they start to accelerate again. This is the same with the weaker player. This can show that maybe both the players have seen it's the final 5 meters and have decided to give it one last push in order to get the quickest time possible. This graph shows the comparisons of the 3/4 sprint times. As you can see, my performer in the yellow had a fairly okay time of 3.21 seconds. This time is quicker than the group average, which was 3.7 seconds. This shows that even though my performer wasn't perfect, they were still quicker than the group average, meaning that they are not going to be, this shows that even though there is room for improvement, they are not completely awful or weak in this area. Again, from this time, we can compare it to the normative data for males and females in the UK, and we can see that my performer's time, as they are a male, is under the excellent category for the whole of the UK. However, my performer's time compared to the better player and the NBA elite player is still very weak, as both the NBA elite player and the better player had times of under 2.5 seconds. And this shows that in order to be a top level player, you need a high level of acceleration and speed. This will help you in basketball, as I've previously said, to win 50-50s, and it will also help you to get up and down the court faster. As if you're able to get up and down the court faster, it means you may create more space for yourself and more uncontested shots, meaning you have a better chance of scoring. Whereas if you are slower and it takes you longer to get up to the other end of the court, more of the other team's defense will have got back and will be marking you, which will mean it will be harder for you to get off an uncontested shot. Next, moving on to the results for vertical jump. On the top graph, we can see the comparisons of vertical jump heights. We can see again that my performer is in yellow, and they have a fairly good vertical jump height of 56 centimeters. This means this compared to the group average is very good, as the group average is only 48 centimeters. This shows that my player has a vertical jump that is 8 centimeters higher than the group average. It will be beneficial for them as they are a small forward, as they need to be able to get up and get rebounds. It will also help them to block other players' shots, as they will be able to get up higher. However, my performance score compared to the NBA elite player is very weak, as the NBA elite player is 97 centimeters. This shows that there is a lot of improvement that my weaker player could be doing in order to get a higher vertical jump. However, it is unrealistic to compare someone who doesn't really play basketball to an elite NBA player. So compared to the better player in our group, which had a score of 72, my performance was still weaker than them, but by not as much of a margin as they were to the NBA elite player. This shows that if my player came up against a better player, they would have a disadvantage as they cannot jump as high. This will disadvantage them in different scenarios in the game, such as blocking shots and offensive and defensive rebounds. The graph below shows the comparison of peak power during the vertical jump. As you can see, my performer has a peak power of 4,968.2, and the better performer has a score of 5,622.3. This shows that the better performer produces the highest amount of power out of the two performers. This will also have an impact on the height in which they can jump, and again will have the same negative effects as the vertical jump height, as it will mean that my performer will be disadvantaged when it comes to scenarios like blocking the ball and offensive and defensive rebounds, as there will be players that they play against who will be able to jump higher than them. Once again, an NBA elite player has a peak power of 8,362.9, which is much higher than either of my performers, but this is to be expected as the NBA elite player trains specifically for this sport. Next, I will be evaluating the use of the numerical model. There are both advantages and disadvantages to using a numerical model. Some of the advantages are that the numerical model uses numbers instead of wordy explanations. This is an advantage, as you can look at the numbers and you can easily see the difference between one performer and the other, whereas if you were to use wordy explanations, it would be more confusing for someone who is less experienced to understand the differences. Another advantage is the numerical model states basic facts and statistics. This is good because it will allow someone who isn't very confident or experienced to understand the facts and figures about what is going on, and this will also make it easier to analyse the results. A final advantage is that it is easy to compare. This is a good thing because it will allow coaches to compare one player to another in order to see what the weaknesses and strengths of their squads are. Next are the disadvantages. One disadvantage is there is no context to these results. This means that the athletes will not be given any context to why their results are what they are. For example, it could say that one person is not very good at three-point shooting, but it will not say whether or not the shot was contested, which would have a significant impact on the result. Another disadvantage is that you often need experience to carry out most of these tests. This is a negative because it will mean that a lot of smaller teams or clubs will not have, or organisations will not have access to the correct equipment, meaning they'll have to settle for the less accurate testing methods. The final negative is that it can be expensive to perform. We found this out as we were unable to purchase things such as force plates and speed gates. So therefore we had to settle for less accurate tests, and this would have an effect on the results, and therefore will have an effect on analysing the results. Thank you for watching my 6.3 screencast.